Here is friction example number 1. To save a little bit of time, I've already drawn in for you the equation for the force of friction is mu times the normal or perpendicular force. And remember, perpendicular sign means normal or at right angles to the direction of motion, which is along the level surface. There are two mu's, a static version, and I have not told you the kinetic value. But I have told you that I am pulling this 12 kilogram mass, or attempting to pull it to the right, with 70 newtons of force. And I find that it accelerates. So there probably is motion because it's accelerating. So we want you to find the kinetic coefficient of friction. So first of all, would 70 get this block moving? Well, the force of friction is equal to mu, and if we look at the static one, is less than or equal to mu static times the normal force, which is 0.5 times m, which is 12, times g, which is 10. So half of 120 is 60 newtons. The maximum static pull force is 60 newtons, and we are pulling with 70. 70 is larger than 60, so we are overcoming the static friction force, and we now need to use mu kinetic. So the force of friction is mu kinetic times the normal force, perpendicular force, which is the weight, mg. M is 12, g is 10, 120 times mu kinetic is going to be the friction force opposing me. So the net force, according to Newton's second law, is ma, which in this case would be the pull in that direction, F pull, minus the force of friction kinetic, whatever the friction force is on between these two surfaces. So I know what the mass is, it's 12. So 12 times the acceleration, which I was given, it's 4, is equal to F pull, which I know to be 70, minus the force of friction, which is 120 mu kinetic. So 12 times 4 is 48, and so 48 is equal to 70 minus 120 mu k. So I could bring the 70 over here and get 22 newtons minus is equal to minus 120 mu k. So by dividing by negative 120, I get 22 over 120, and that's mu kinetic. And can we simplify that at all? Well, this is about 121. So dividing by 11, it's like 2 over 11, about 2/11. So it is certainly less than a half. So we know that the kinetic mu is, as it should be, less than the static one. And we were able to find it because we knew everything in Newton's second law equation, except for the mu k value in the force of kinetic friction, which is mu times the normal perpendicular force. Let's do another example where we have a rope connecting two masses, and then we'll move on to what some students consider to be the most daunting type of friction force, friction on an inclined plane. Once somebody shows you how to draw it, it's no big deal. But most teachers don't stop and break it down step by step. They just draw it on the board and figure out everybody will go home and think about it for hours. No, you won't. You'll do things that are pleasurable, play games, talk with your friends, play pool, whatever you want to do. Go practice extra soccer after you go do your extracurricular activities. You're not going to sit at home and ponder about an inclined plane. So your teacher does you a disservice when they don't break it down step by step and teach you how to draw it. So that's what we're going to do as we continue, we're going to do one more on a level surface and then inclined plane. I'll teach you how to draw one and how to do the calculations involved with that. They are cumbersome, long, but they are not hard. You won't need to skip these problems on the SSAT.